Today we start section 6.3, and we're going to spend a couple of days here, but this is solving systems by elimination. So now remember, we've learned how to solve through graphing and through substitution, and now I'm going to teach you the third method, which oftentimes ends up being a favorite, is elimination. So still a reminder, the solutions to a system of equation can happen one of three ways. We either have intersecting lines where we get exactly one solution that we write as an ordered pair. We have parallel lines which do not have any solutions because they never intersect. When solving these algebraically, remember we lose the variable and we end up with a statement like you see there that says 10 equals 3, so that's false. Or we could have the same line, and when we have the same line, it's infinitely many solutions. We would lose the variable as we're solving, and we would end up with a true statement. Like you see here, 10 equals 10. So again, a reminder, the first section we covered was graphing, solving systems by graphing. That was 6.1. Then in our previous lesson, we learned how to solve through substitution. That was 6.2. And now we're going to spend a few days learning how to solve through elimination. So this is how you solve systems of equations using elimination. So the first thing we're going to do is look for opposites on the same variable. So here are some examples of opposites. We might see one equation that has a 2x and the other one has a negative 2x. We might see an equation that has 5x while another equation has negative 5x. And it doesn't always have to happen on the x variable. It could happen on the y variable. For example, you could see negative 6y on one equation and in the other equation could be a positive 6y. Once you have that, we're going to add or subtract the equations. Sorry about that. So we're going to add or subtract the equations to eliminate one of the variables. And it will be the variable that has the opposites. Once we have that done, we're going to solve that equation and we're going to get one of the variables to have an answer. And we're going to plug that back in to an equation to find the other variables, similar to how we did it with substitution. And then we always write our answer as an ordered pair. So let's do some examples. Solve by elimination are all the instructions today. The first equation is x plus y equals 1, and the second one says x minus y equals 3. You can see that the y variable is the one that has opposite coefficients. We have a positive 1 in front of the y, and we have a negative 1 in front of the other y. So since we have that set up, we're just going to draw a line underneath. And then I think of it as addition. I'm going to add these two equations together. So if I have an x and an x, I now have 2x. My y's have eliminated. Positive 1y and a negative 1y would be 0y. I'm going to bring down the equal sign and I'm going to add over here. 3 plus 1 is 4. Now I have a one-step equation. I'm just going to divide both sides by 2 to solve for x, and I get x equals 2. So the first part of my ordered pair has a 2 as the x coordinate. Now I'm going to take that answer and I'm going to plug it into either the first or the second equation. It doesn't matter. Here, it's not as easy as yesterday where we had the other equation solved for a variable. Now we're just going to plug it into either one. I'm going to plug a 2 into that first equation for x. I don't know what y is. I'm going to set it equal to 1. I'm going to subtract 2 from both sides. Now we get y equals negative 1. So the solution to this system of equations is 2, negative 1. 3x plus 5y equals 15, and 2x minus 5y equals 10. So you can see that the y's have the opposite coefficients on them. So when we add the two equations together, the y's are going to cancel. 3x plus 2x is 5x, and 15 plus 10 is 25. And we're going to solve for x. X equals 5, and now we're going to plug that in to either the first or the second equation to solve for x. I'm going to go, solve for y. I'm going to go ahead and plug that into the first equation. I typically just prefer not to deal with negatives. I don't know, it makes things a little easier in my opinion, so that's usually what I try to look for, or possibly an equation that maybe has the smaller coefficients. But 3 times 5 plus 5y equals 15. 3 times 5 is 15. So remember, we're solving this equation for y. Subtract 15 from both sides. 5y equals 0. Dividing both sides by 5, and we get y equals 0. So the solution to this system, remember again what that means. It is where on the graph these two lines would intersect at 5, 0. Number 3, 4x plus y equals 13 and 3x minus y equals 8. Again, you can see that it's the y's that have the opposite coefficients, so those are going to cancel out. 4x plus 3x is 7x, and 13 plus 8 is 21. Dividing both sides by 7, we find that x equals 3. Now we're going to take that and plug it back in. I'll just use the first equation again. 4 times 3 plus y equals 13. 4 times 3 is 12. Subtracting 12 from both sides gives us y equals 1. And so the solution to this system is 3, 1. Number 4, 3x plus y equals 10 and negative 2x plus y equals negative 5. Hopefully what you see here is that we actually don't have either variable with the opposite coefficient in front. We've got a 3 and a negative 2 in front of the x's, but we have positive ones in front of the y. We can fix this kind of quickly. I can multiply either the top or the bottom equation, it does not matter, by a negative 1, and that's going to change the sign in front of this y. It's going to change the sign everywhere, but it'll make this a negative y or minus 1y so that it will cancel or eliminate with the first equation. So I'm just going to rewrite the top equation. I'm not doing anything with that one. And I'm going to multiply everything in the second equation by negative 1. Now you can see when I add the two equations together, the y's are going to eliminate. So that's 5x. And it equals 15. So we get x equals 3. And I'll go ahead and plug it into that first equation. So 3 times 3 plus y equals 10. And subtracting 9 from both sides, we get y equals 1. So the solution to this system is 3, 1. A couple more examples. We've got 2x plus y equals 7 and negative 3x plus y equals negative 3. Again, I've got a 1 in front of both of the y's, but they aren't the same sign. So I need to multiply one of the equations by negative 1. I'm going to go ahead and do this bottom one again. And I like to rewrite the equation that I didn't do anything with. I just like to stack them on top of each other. So my y's are again going to eliminate. We haven't done an example yet where x's eliminate, but it is possible and it works the exact same way. You just find y first and then find x. So this is 5x equals 10. Dividing both sides by 5, and we get that x equals 2. I'm going to plug that 2 into the first equation, plugging it in 4x. And we get y equals 3. Okay, one more example here. These two equations are now written a little bit differently. Instead of being in standard form, they are in slope-intercept form, and that doesn't matter. You can subtract the x's over to the other side if you prefer to see it that way, or you can still leave it like this. You can do elimination as long as everything in the two equations lines up with each other. So you want the y's lined up, you want the x's lined up, and you want the constant lined up. You don't want to have one equation in standard form and the other equation in slope-intercept form. We wouldn't use elimination for that method. But here I have 1y and 1y. Those are both positive. And I actually have two positive x's here, both positive 3x. So I'm going to go ahead and multiply the top equation this time by negative 1. So that's going to give me negative y equals negative 3x minus 9. And my second equation has not changed. And now I'm going to add them together. So my y's are going to eliminate. That leaves me with a 0 on the left-hand side. And actually what you see here is our x's are going to eliminate as well. Negative 3x and 3x is 0x. So now I just have negative 9 minus 16, or negative 9 and negative 9 and negative 6, however you want to think about it. But that's minus or negative 15. And so now I've lost the variable. This is one of our special cases. When you lose the variable, you have to decide, is what I'm left with a true statement? This is not true. 0 does not equal negative 15. And so in this case, we have no solution. And remember that if we have a system of equations with no solution, it means that the lines never intersect. And so think about what kind of lines are never going to intersect, and those are parallel lines. If we graphed these, we would be graphing parallel lines. So you've now been introduced to the first three methods, graphing, substitution, and elimination. Most students prefer elimination. We do want to introduce you and have you practice all of them. So when we get to class, I will check the video, your notes, and we will work on worksheet 6.3a.